It's me again, Margaret. We are on to section 2.3, quadratic graph diagnostics. Yes, diagnostics will be something that you have to do for all types of graphs. So here we are. Essential questions. How do you find the domain? How do you find the range? How do you find intervals of increase and decrease? What about positive and negative? All of these essential questions are going to be answered in this video, and all of the answers have to be in interval notation. So I hope you took section 2.2 seriously. Now, before we get into domain and range and increase, decrease, positive and negative, I want to talk about axis of symmetry. You did this in Math 1. This is just a dump of all kinds of images I found of what an axis of symmetry is. It is a vertical line that goes smack dab through the vertex, and if you fold it along that line, it would match up. A symmetrical line, okay? A symmetrical graph. And all of these are some examples of different things. What I'm going to want you to write down is this. This is note card 42 on axis of symmetry. So pause me and get this stuff going. Had to edit that a little bit. My goodness. Okay, so again, this should be a reminder, but the axis of symmetry of a parabola is a vertical line in the form of x equals that divides the parabola into two congruent halves. The x-coordinate of the vertex is the equation of the axis of symmetry. So you write it as x equals whatever that number is. We learned how to find the vertex, the x value of the vertex, the h, as negative b over 2a. We already done that. And so given standard form, your axis of symmetry is x equals negative b over 2a. Now, if you're given vertex form, it's just the h, because that's the nice thing about vertex form, is you can pull off the vertex really quick, and it's just the x value of the vertex. So remember, these are in x equal because it's a vertical line. It hits the x-axis, and it's an equation, so it's x equals. And it's the same whether it opens up or opens down. Remember, it opens up if A is positive, and it opens down if A is negative. All right, so here's an example of finding the axis of symmetry. Oh, goodness. Okay. So how do I find, the bell, the axis of symmetry? And I did this here as a reference. This is in standard form, so we're going to use the negative b over 2a method. Let me go. Why are we not working? Okay. So to get the x value of the vertex, which is the axis of symmetry, x equals negative b, so that's b, over 2a, that's a, so 8 over 4, and we get 2. So our axis of symmetry, which I like to write as AOS, or of course you can write it all the way out if you want to, is x equals 2. If you just write 2, you'll get partial credit because it is an equation of a line, so it has to have x equals 2. So here we are back at the slides, and here's the work that I just did. So pause me and finish up note card 43. All right, next, we're going to move on to diagnostics. Okay, so note card 44 is about domain. The domain of a function is a set of all real values of x that will give real values for y. That probably doesn't mean a lot to you. Another way you could say it is the domain of a function consists of all of the x values that make up the graph. That makes a little bit more sense to me. And then the Sharpism. The last one is that what I call a Sharpism. You won't find this in a textbook, but this is how I explain it. To find the domain of a function, you can imagine cutting the graph with the x-axis and then smushing it towards the x-axis. Whatever x values will be bold or smush to the x-axis make up your domain. That will not make sense to you until I do some examples, but that's what I'll be talking about, smushing. I know that's weird, but smushing, all right? So pause me and finish up note card 44. All right, so this is note card 45. It's an example of finding the domain. If you notice, it's a parabola. It has a vertex at 2, -7. It opens up. By the way, its axis of symmetry would be x equals 2. And the way I like to imagine this is if you would cut this, what did I say? I said, imagine cutting the graph with the x-axis and then smushing it towards the x-axis. So if I cut this, I would have this part, and this part, and I would smush. So I'm going to show you what I mean. Okay, so I know my graph's not as good as the computer generated, but it'll be okay. All right, so I always just imagine making my graph into different pieces around the x-axis. So I've got 3 different highlighters. This would be a piece. This would be a piece because these are would all be different pieces if I were to cut it along the x-axis, okay? Then I imagine smushing those pieces down to the x-axis. So what would this pink cover? Well, look, these are x values that go on forever. They're unbounded. So this pink would cover everything this way. And it's unbounded. This would just keep getting wider and wider. If you didn't know it, parabolas get wider and wider, okay? They get wider as they go. Now the orange would just smush just right here. And the purple is very similar to the pink. It would smush, this keeps getting wider. So X value, let's say of 20, 30, 40, 50, 100, 1 million. So it would be all of this and it's unbounded. And if I look, the whole x-axis would be covered. And that's going to happen for all parabolas that open up or down. Okay, you might be thinking, when does a parabola not open up or down? Guys, you'll see those later. Those are sideways parabolas. We are not doing those yet. Okay, so for all parabolas that open up or down, the whole x-axis would be covered. And so your domain would be all real numbers. And so if you talked about this in Math 1, you probably wrote something like domain, and you used this symbol like so, all real numbers. Maybe you didn't. Maybe you didn't. The inequality notation is negative infinity less than x less than infinity, and you can also have equal to's on that, but the interval notation, which is what you will need to do from now on, unless I ask you something differently, if I ask you to do it a different way, but your interval notation, once you realize it's everything, that it covers the whole x-axis, this is like what we were doing in section 2.2. The whole x-axis is covered. So what would that be? That would be negative infinity span to infinity. So the domain, I'm going to put D for domain, is negative infinity to infinity. All right, so here we are back on the slide. So you can see why the domain is negative infinity to infinity. So the answer is parentheses negative infinity, comma, for span to infinity. That was note card 45. Now, oh, pause me if you need to. All right, note card 46 is range. This is the same thing as domain. Oh, well, hold on, except we're looking at y values. So it is the set of all real values of y that give real values for x. Okay. The range of a function consists of all the y values that make up the graph. Okay. Sharpism. Okay. To find the range of a function, you can imagine cutting the graph with the y-axis and then smushing it towards the y-axis. Whatever values would be bold or smushed to the y-axis make up your range. La, 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 la. Pause me, write that down. So now it's time to do an example of range. This is the same graph that I had before, and I want to show you about the smushing thing I talk about. And yeah, fun. Okay, so here's another version of the graph. And remember, with domain, always with parabolas open up and down, it's negative infinity to infinity. Of course, that's something you can memorize, but I'd rather you understand why. And with range, it's different. With range, we are bounded. We are bounded below. Okay, nothing goes below this y value of -7, nothing. So it's not going to be negative infinity to infinity. So again, I'd like to imagine that we're going to cut it right here, and we've got some different pieces. We have this piece, and we have this piece. Okay, now we need to imagine smushing them to the y-axis. So smush, 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 smush. All that would be covered with the pink. And then, whoop, it wanted to make another appearance. Smush, 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 Stop smushing there. Nothing below that. So yes, the orange would go over top of the pink, but then it would also go here all the way down to what y value? What would this y value be? That y value is -7. So my range, we have to go from bottom to top. Okay, so when we are writing our range, we have to go from bottom to top. It's very important, bottom to top. And so just like with domain, we go left to right, smaller to bigger, okay? So bottom to top, your smaller y values are down here. Now, this is a closed circle. That's the smallest y value. It is a closed circle, so it's going to be bracket, -7, and then all the way up, these y values are getting bigger and bigger and bigger and bigger and bigger. This is infinity up here, getting bigger and bigger. In terms of y, that's infinity, okay? So all the way to infinity, and remember, infinities cannot have a bracket on them because they're not a tangible number that you can grab. All right, so our range is this. Okay, so there is the graph that I just did with you and the answer to note card 47. Make sure you're drawing these. That's part of the example. So make sure you're doing that. So pause me and finish up note card 47. Note card 48, we got to talk about increasing. A graph is increasing if it rises from left to right. Pause me and write that down. All right, so note card 49, I want to do an example of increasing, and I've got a different graph here. Now remember, if you're not given the graph, just go to Desmos and type it in, and you can see the graph, or go to your calculator and type it in. Okay, so here's the graph. Where's it increasing? I just told you in note card 48 that a graph is increasing if it rises from left to right. If it rises from left to right. So from left to right, where is this thing rising? So if I start on the left, this is going down. That's falling, so that's not it. But right here, whoa, I'm not good at drawing with this thing. But right there, that is rising. It's going up, okay? So that is where it's increasing. Erase that. Okay, so it is increasing here. I'm gonna try a different tool. I just really didn't like that. Oh, okay, that might be a little bit better. So here it is rising from left to right. I gotta start here, left to right. Oh, it's falling. Oh, all of a sudden it's rising. So how would I write that answer? How would I do that? Excuse me while I figure out this this feature on here. But anyway, so it's increasing in this area, and I have to write it in interval notation, left to right. So what is that leftmost x value? You use x values. That's 1. Now with increasing and decreasing, we will never use a bracket because we never can increase and decrease at an actual single point. So we always use parentheses with increasing and decreasing. So it's 1 span. Now is this going to continue increasing forever and ever and ever and ever and ever? Yes. So it's 1 to infinity in a parenthesis there. Now I might be able to insert a special character, and that just went away, and I did not want that to happen. I don't even know. So much for me trying to use that. Oh, there we go. There we go. I get the, the little infinity symbol. But that is the answer. And let's see. Yeah. So what you do is you find where it's increasing, and then you go the leftmost x value, which is 1, comma, forever and ever, on forever to infinity with parentheses around it. Remember, increasing and decreasing will always only have parentheses. Okay. Oh, move that. Okay. So there you go. I can't tell. Oh yeah, it is recording. Okay. So that was the increasing. Now, what do you think decreasing? You probably already know the answer to this one, but let's go on to our next note card, number 50. A graph is decreasing if it falls from left to right. So let's look at this. Oh, pause, write that down. Let's look at this example of decreasing. I was not a big fan of how that worked out, so I'm going to try something different. Hold on. of course, this isn't going to be ideal, but where is this falling from left to right? It's falling from left to right, right here. Okay, so it's gonna, no matter how far left I go, all right, it's going to be, and then I start going right, it's going to be falling down, okay? So it's going to be from negative infinity, because these are x values are negative way over here, all the way to 1. So maybe that just makes sense to you. So you can just go ahead and write the answer. It would be negative infinity. Hopefully you use the infinity symbol all the way to 1. Okay, remember, increasing and decreasing, you don't use brackets. All right, you use parentheses only. Now, decreasing, so I'm going to take this and move this. I can't quite highlight, but it's decreasing all this side. It's going down all of this side. Let's see. Let me scribble. Okay, so that is decreasing. All over there is decreasing. Well, that's kind of neat. All right, so it is decreasing from negative infinity to 1. So back up here, back to your note card 50. We need to add something to it. So go to your note card 50. I want you to add that only use parentheses. Okay, you only use parentheses with this. Only use parentheses. And so you need to go back to another note card and add that to note card 48. I want you to add that there as well. Only use parentheses. Okay. And then remember, you notate it. When I say notate, I mean when you write down the answer, you notate with x values from left to right. Okay, how we notate. Even though we're looking at it, with y's, we notate it with x values from left to right. Same thing, back to note card 50, I want you to add that. We notate with x values from left to right. Pause me if you need to get caught up there, because I'm going to go to some other former note cards that we did. I want to go back to the domain. I want you to go to note card 44, and I want you to add that we notate with x values from left to right. Okay, pause me if you need to. And then I want you to go to range, which is note card 46, and I want you to add that we notate with y values. This is the only one that we notate with y values from bottom to top. So go fix those note cards. Pause me and go fix those note cards. I don't mean fix, I mean add. Okay, so hopefully now you're caught up and have added to all of your note cards through note card 51. So now we're going to go to note card 52, a lot of definitions today. Now we're going to talk about something you may have never talked about before. I'm fairly certain you talked about domain and range, and maybe even increasing and decreasing, okay? But now we're going to be talking about positive, and then we'll do negative, and that's our last thing. A graph, oh, I need to change this. It says increasing. Oh, my goodness. A graph is positive when it is above the x-axis. With parabolas, we're only going to use parentheses, and we notate with x values from left to right. So pause me and get that finished. All right, welcome back. So let's do an example. Note card 53, example of positive. So if we look at this, it dips below the x-axis. I want to know where it's positive. And guys, remember, that is where it is above the x-axis. This is above the x-axis, 2 different places. Here, look where I'm hovering, and here. Okay, so you've got to determine where is it above the x-axis. Here and here. Once you determine that, you notate it with x values from left to right. So from here to here, okay? So it's going to be positive forever and ever and ever this way. So that's going to be, we notate with x values. So all the way negative infinity, look where I'm doing, all the way up to, and I included this ordered pair so you can see that was negative 2. Okay, so that's one of the answers. But there's another set, so we have to have a union. And the other set starts here. So union 4, and then it's going to keep being above the x-axis forever, so comma to infinity. I'm going to go over that using the document camera, so give me a hot second. So here's my rendition of that graph. I do have the necessary tick marks labeled right here, negative 2 and 4. I don't really care about how low it goes because I'm just talking about where is it positive. Now I know it's positive here, and I know it's positive here because positive means when it's above the x-axis. So I need to write down interval notation for both the pink and the purple part of the graph. Now remember, we're notating with x values, okay? We're notating with x values. So if I smoosh this down, it would be like this. If I smoosh this down, it would be like this. And so how would I write my positive intervals? So let's look at the pink. It would be, remember, this is negative infinity. So negative infinity all the way up to that -2, parentheses, union, because I have a whole nother set. Remember your homework from 2.2 on Delta Math. So we have a union, and then 4, because that's 4, on forever to infinity, And so that's where it's positive. Okay? So there we go. You can finish up note card 53. That's where it's positive. Pause me and finish that up. We're almost finished, guys. All right. So note card 54 is going to go onto the negative realm. A graph is negative when it is below the x-axis. We're going to only use parentheses, and we're going to notate with x values from left to right. Pause me and finish up note card 54. All right, note card 55, same graph, but we want to talk about where it's negative. So where is this negative? That's when it's below the x-axis, so it's literally between -2 and 4, and so your answer is parentheses -2, comma, or span to 4. That's it. Now I'm going to explain it with the document camera for sure. So here we go. So the same information, the same graph, there it is. And I'm going to use my orange highlighter. These colors make me happy. All right, so this is negative. Okay, remember our positive, we had the pink and the purple because they were above the x-axis, and the negative is going to be the orange. Orange. I'm going to do it down here. Decided when I go take my picture and bring it back to the slideshow, it's going to be better to have it like, okay. So how do I notate that? Remember, I notate it with the x values from left to right. Now, if you get confused about that, just imagine smushing this orange up to the x-axis. It would cover all of that. So what is your leftmost x value? It's -2. And what is your rightmost x value? It's 4. And we don't use brackets, and here's why. I haven't explained why. The reason why we don't use brackets with positive and negative is it means it's got to be above or below the x-axis. At -2, I am on the x-axis, so it's not really positive or negative, so I can't include it. And at 4, I'm on the x-axis, so it's not positive or negative, it's neutral as far as that goes, so I can't use a bracket. But there is your interval of negative. All right, so here we go. The negative is the orange. Get your note card finished. We have one more note card that's going to have all of this together. It's like the culminating event of this section. So pause me and get note card 55 finished. Okay, note card 56, full diagnostics example, the culminating event. And notice, I didn't even give you the graph. I gave you the equation in vertex form. Okay, yes, I did. Yes, I did. Now, I know I haven't been all about Desmos and things like that, so I'm going to show you both ways, but I am going to go and type this into Desmos so I can get a nice, pretty graph to drop in here. But this would be something you would need to do. You would need to type it in your calculator, get a nice graph. Oh, I already have it in there. I can't believe I just did that. Oh, I can undo it. Okay, I had already typed it in. Okay, so let me get some important information. I'm gonna, when you're in Desmos, you can go and just like click these things and it tells you, unlike your calculator, and that's the sad thing about me not not encouraging you to use Desmos. I'm only doing that because of the SAT and the pre-ACT and all of that stuff. I really do like Desmos. Anyways, I'm going to drop that in here. Okay, so there's the graph. Again, I'm going to type it in the calculator as well. So here we go. All right. Now, if you haven't done this a lot, which I'm sure you have, You go to my equals, clear out whatever's in there, and I'm going to type this in. I've got negative 1/4 parentheses. That's just the front. That's A. I can just put negative 1/4 without a parenthesis, but I think a good habit when you have negative numbers is to put it in parentheses. And then I have a binomial, x minus 1 squared, and then plus 4. I hit graph. If it's not in this nice little zoom standard window, you can hit zoom right here and then 6. So you can scroll down to 6. I just like to hit 6. And then it would take you to the standard window. And that is this graph, okay? But on Desmos, I can just get these values. I can just find them. On your calculator, it's not so easy. So you have to calculate the maximum. So second, calc, and then 4. And then it says left bound. So this blinky man, is he to the left of that top number? Yes. And then it says right bound. And so blinky man needs to go over here to the right, hit enter, and then just hit enter through yes. And you get that your maximum is 1/4. Now, anytime you see a 0.999999, it's 1. So we know that our maximum or our vertex to this from our calculator is 1/4. I also could just do it by hand or just look. This is in vertex form, 1/4. Now, how would I get these values? Now, you could probably zoom in. Oops. You could probably zoom in and see, or you can guesstimate. Don't ever just guess and be finished. I think it's -3. So one of the quick ways to check yourself is hit trace. That gets you in data entry mode, believe it or not. And then I'm going to type. I'm getting ready to type in -3. So watch, negative, and it brings me up here. -3, enter. And look, the y value is 0. So that is the x-intercept. And the other one I think is 5. So I'm already in data entry mode. So I hit 5, enter. There we go. There's several ways to do that. That's just the way I like to do it. You could go to your table and you could see that 5 and -3, we were right. But guys, just keep in mind, they're not always nice, pretty numbers. So we would have to do some calculations to find those. And when we get to those, I will definitely let you know. All right. So we know that we have a vertex at 1/4. We have an x-intercept at -3 and an x-intercept at 5. And it opens down. I not only know it opens down, and that's an awful parabola, but you know, I know it opens down because of this, but also A is negative. So I need to know that it opens down. So that's the process to graph. If I ever wanted you to graph, that's definitely what I would want you to do. And now let's answer these questions. This is diagnostics all the way. So the vertex is 1/4. That's an ordered pair 1/4. What is the A value? The A value is -1/4. And guys, what does that imply? That implies that it opens downward. What are your x-intercepts? We found them. Those are my solutions if I were to set it equal to 0. They are -3 and 5. We also can see it right here on the graph. What is the axis of symmetry? That was something that we did at the beginning of the lesson 28 minutes ago. So the equation of the axis of symmetry is x equals 1. It is this straight vertical line, and it goes right through the x value of the vertex or the vertex. So it's x equals 1. So this is where I'd say stop and graph if you haven't already, because all of those things you can just get from the equation. And so there's the graph, there's the graph. All right, we ready for this? We got domain, range, increasing, decreasing, positive, negative. So I'm going to go over here to my little graph and do all of these, and then we'll transfer it over there. All right, so let's start with the domain. Remember, for a domain, you look at it, you notate it left to right. And I like to imagine splitting these into little sections that are cut by the x-axis. And then I imagine smushing these towards the x-axis. So the orange would go up here, and it would cover all of that. The purple would go down here, and it would cover all of that. And the pink would go up here, and it would cover all of that. So the pink goes on forever, the orange goes on forever, and the purple fills in the gaps. And I know I said you could just go all real numbers, negative infinity to infinity, but I want you to understand that it covers the whole x-axis, so my domain is negative infinity to infinity. Now my range, it's a different ballgame. And so I'm just going to sketch this really quickly again because I use those colors. All right. And for the range, I need the vertex. So this is 1, 4. So this top y value is 4. And I imagine smushing it to the y-axis, just like I smush up here to the x-axis to find the domain, to find the range, I imagine smushing this to the y-axis. And if I look at where the y-axis cuts it here, right? The purple would go like this and cover all of that. And the pink would, it's bounded by that 4. And it would cover this little part and everything else. Okay, cover all that too. So what is my range? Now remember I had you add in something to this next part. You notate with y values in the bottom of the top. So your y values are going to be negative infinity down here because they go on forever towards the negative realm. Negative infinity all the way up to a y value of 4. So negative infinity to 4 with a bracket because that's included. Okay, now increasing and decreasing. Increasing and decreasing. Okay, back to this. I'm going to draw another quick graph. This was the vertex 1, 4. Where is this thing increasing? Remember, that's where it's rising from left to right. And guys, that is right here. That is increasing right there. So from left to right, it's going up. And we notate with x values, and we only use parentheses. So as x's get smaller, it's still going to be increasing. Still like no matter what x, so like negative 100, it's still, if I start there, it's still increasing. So I'm increasing from negative infinity all the way up to what x value, because we notate with x values, all the way up to 1, using parentheses only. Now, where is this thing decreasing? It is decreasing or falling from the x value of 1, and it's going to keep happening as x's get larger. So from 1 to infinity, that's where it's decreasing. And again, pause me, rewind me, slow me down, all of that. We've got 2 more to do. These markers have a mind of their own. Now we're going to look at positive and negative. Now this is where I really need to be cognizant of the x-intercepts. They were negative 3 and 5. Let me just double check that. Yeah, they were. Okay. And oh, that's a struggle bus, but you know what I mean. I've got a pretty graph over there for you. Okay, so where is this thing positive? And where is this thing negative? Now it is positive above the x-axis, so I have this. Only one spot, and I go left to right, so it'd be negative 3 to 5 with parentheses only. I explained why earlier, but it's because those are actual x-intercepts, and they're neutral. They're not positive or negative. Now, where is this thing negative? Well, it's below the x-axis here, and it's below the x-axis here. And guys, those aren't bounded, okay? They're not bounded. So we're going to have an infinity in here, just like right here with, this was when I was going over the range. You know, this was unbounded, so that's why we had to start with a negative infinity, okay? And my domain was unbounded both ways. That's why we had infinities. All right, increasing, same thing right here. This kept going, and this keeps going. That's why we have some infinity. So back to this. Sorry, I just wanted to emphasize that. All right, so we have 2 different spots, so we'll have a union, and we notate with x values. So this is negative infinity, and this is infinity. So the first pink would be negative infinity up to negative 3, like that, and then union 5 right here to infinity. And that is your negative intervals, or those are your negative intervals. That was just a blast. Okay, so here we are back to the summary slide for note card 56, 34 and a half minutes in. You guys are rock stars. I dropped in what I had done on the document camera. You can zoom in and see different things if the colors are helping you. I filled in the answers over here. Guys, this is very difficult. It is very difficult, okay? This is not something that I expect you just to get right away. It's tricky, and I oftentimes, it'll be like during math 3 when a light bulb will come on with diagnostics. I hope it doesn't take you that long, but just try your best and know that you're going to feel uncomfortable with this. You're going to feel not very confident, and that's normal, and that's so sad to say, but I just wanted you to know that. If you got this far, way to go. I'm super proud of you. We're going to be doing this again next week. So just know that we will keep practicing this. So please don't stress out. Just do the best you can do, and it's all going to be all right. Email me. Let me know you got this far in the 2.3 video, which is really past 35 minutes, almost 36 minutes, my longest single video to date. Yes, I know. Fun.